and biology, medical. Any other field beside this? So you are from which field? Okay, okay. So all in the science background, right? So I'll try to make a cumulative effort to make it very simple to the students who are not in chemistry background as well. My efforts would be there to tell you, or I'll say that give you a glimpse that what research is and how you can make your mind for doing a fruitful research. Because whenever we talk about research, we were just talking right now when we were taking a lunch, that research is something where we just imagine, oh, someone is going to the lab and just doing something and come out with a thesis that hardly anyone can understand. That's most of the perception. So because you are you are the young mind and you are the flag bearers who really will be the one who will inspire the young generation, and as well as you will change our nation. So why we are talking about NEP, new education policy, and all other things. So how it is possible? Just because teaching research into the course, do you think that research will ultimately come into our society? Being a researcher, I literally doubt. Because research is the one thing where you are working on some problem, you are giving your input into that problem, you are trying to come up with a theory that actually has some implication in a real life. So research is a thing where you really have to, pick up the problem. Picking up the problem is really a very important thing for a researcher, that I'll say. Because mostly when we end up in a research or whenever we are looking for a guide, we just say, okay, is there anyone who will just give a PhD without, just doing some basic work? So if you are moving with this approach, let me say you will never come up with good things. So if you really want to contribute something, you really have to be there, that who can assist you in designing a particular problem. What problem are you choosing with the help of your supervisor? That is of a relevance to the society. So, can I take that? Yes. Okay, thank you. So, thank you very much. So, this is ready. So, I will be discussing designing of nanocarbon-based catalysts for conversion of biomass into biofuels. So, before starting my talk, let us spend a few things about the title. So here I'm going to talk about nanocarbon, because we already have a very good talk about use of a nanocarbon material, so you all have a little idea that what nanocarbon materials are. So here in this particular case, I'm going to use these carbon materials that too as a catalyst for the conversion of biomass into biofuels. So that is the one term that we really need to focus, that what is the conversion of biomass and why these biofuels are important and why people are talking about all these things these days. So I think most of the everyone have studied chemistry in your BSc classes, right? So when we talk about carbon, we just know one thing. What is that catalyst? Can anyone name me? कोई कार्बन कैटलिस्ट किसी ने पढ़ा हो, यूज किया हो? Any chemistry student? No idea? Platinum and carbon, very common. Palladium and carbon, very common. These are the very common things that we are using from ages. From the time chemistry start developing, industrial revolution. Carbon, you are using a metal, doping it on the carbon and doing some chemical reaction. And the most common chemical reaction that we used to perform with this carbon catalyst is hydrogenation. Very, very fundamental reaction that we generally use. And if you are a physicist, if you are studying physics, you know that we have a carbon where we define that what activated carbon is, what carbon black is, and what carbon aerogel is. So these are the different forms, different for a physics person and different for a chemistry person. So for a physicist, I think you will be more interested about the crystallinity of these compounds, that how you can differentiate these. But for a chemist, they are different surfaces where you can play with the adsorption and desorption. So now coming to the new age compounds. Here you can see. Now in the new age, we have a new class of nanocarbon catalyst. So nanocarbon, we have the first generation, the second generation, and the third generation. So this is a very basic that I always discuss in most of my lectures that you should know. The first generation is the one where we have fullerene, graphene, carbon nanotubes, and nanohorns, nanofibers, nanodiamonds. In the second generation, what we do, that in order to enhance the activity of these carbon materials, what we do is that we try to change one carbon atom with some other heteroatom. For example, if you see here n-doped graphene. So graphene is a single layer of graphite sheet. If you graphite, I think everyone know that you have multiple flat layers which are stacked one above the other. मतलब एक तरह का सैंडविच है, बन गया एक लेयर के ऊपर एक, किताबों का ढेर जैसे होता है। वैसे ही कार्बन लेयर्स हैं जो एक दूसरे के ऊपर है, इलेक्ट्रॉन्स कंडक्ट करती हैं, दे आर कंडक्टिंग इलेक्ट्रॉन्स। अब इनकी एफिशिएंसी हमने बढ़ाई, कैसे बढ़ाई? नाइट्रोजन एटम डाल दिया। व्हाट वी डू, along with nitrogen we also added boron atom, and we make a hybrid of these compounds. You can see the third generation of carbon material. How we make the hybrids? We take carbon nanotubes, we are growing them on nanofiber. Nanofiber is a bigger aspect. Nanotube is very small in dimension. Generally we get confused what's the difference between nanofiber and nanotube. So you can see in the image as well, there is a very long backbone and a very small branches coming out of it. So these are the tubes grown on nanofiber. So we can make a hybrid of nanotube and fullerene, sometimes graphene and CNT. So this is the continuous work that we are still doing. We are trying to attain new and new structures. For example, 15 to 20 years before, no one has imagined about graphene. I had an opportunity to interact with that guy when I was doing a postdoc in China, and lecture was really marvelous. And when we just asked a question, so what inspired you to create this graphene? That he gave a very simple answer. Frankly speaking, whenever I started my PhD, I never imagined that I'm going to discover this graphene. Graphene was never in my mind. I was just working honestly with some carbon material, and one day we just observed that this is something unusual. That is the journey of PhD. He doesn't come with a fixed mind that I'm going to create or discover something unusual. He was just working with graphite, and accidentally he discovered that he has some material which is very much different from graphene, graphite, and very different properties as compared to graphite, and giving some unique properties, and that's how he discovered. So that is what I'm saying. Whatever you are doing, you have to put your sincere efforts into that so that the best outcome can be attained. That should be the approach to move ahead in life. So now when it comes to chemistry, okay, now I want to use carbon materials for my chemical reactions. How can I do that? I need to tune, as I say, I think all of you are aware with adsorption, even the physics and mathematics people, right? Means when something gets attached to the surface of anything is called an adsorption. So that is, I think you can interrupt me. If you don't understand anything, you can just raise a hand, and it's okay to interrupt me whenever I am discussing any point, I don't mind. So rather I will be happy if you ask question. Meanwhile I am discussing any type of query, and no question is stupid, always remember that. So I'm here, I would be very happy if someone takes away something from this presentation and applies it to your personal development and development of the society, and that's the purpose of every teacher and every researcher. That's what we are here for. So if I need to modify the carbon for chemical reactions, what I am going to do is, so if you see this nanocarbon, I am going to make it, either I can make the carbon nanotubes, the graphene, or three-dimensional porous structures, and I need to surface modify them. Surface modify, I will tell you a little bit in my next slides, but I'm just telling you. For example, heteroatom doping, as I tell you that graphene, if you are inserting some other foreign atom than carbon, it is heteroatom doping. So if I can do heteroatom doping, surface modification, I can modify their edges, I can just do single atom metal coordinated complexes, and these are the few things that I can do with the carbon materials to make efficient materials for chemical conversion, including developing the processes for chemical change and energy change. That's the main thing that we can do. So coming to the theme of the conference, the energy change, now I'll be a little bit discussing the biomass valorization. So I hope, if you don't know this term, I think we all are aware that no one these days wants to use those fossil fuels. I don't want to use petroleum. I don't want to use diesel. Why? They are causing global warming. They are exerting lot of nitric oxides, N oxides into the environment that are not good. Delhi is so much polluted.